Hello, welcome everyone. My name is Sadat Sud Muhammad, mathematics teacher. Today we will learn about areas and perimeter. So, at the end of this lesson, you'll be able to define a regular polygon, that's number one. Define perimeter of a regular polygon, that's number two. Derive the formula for the length of one side of n-sided regular polygon. But number three, deduce the formula of the perimeter of a regular polygon. That number four, calculate the length of one side of a regular polygon. That number five. And the final one is calculate the perimeter of a regular polygon. My dear viewers, let us have a look of the following figures. We have rectangle, hexagon, pentagon, and triangle. From the figure shown here, please answer the following questions. Number one, which figure has 5 sides? Number two, what is the name given to the figure with the 6 sides? And number three, how many polygons have you observed all together? Please take your time to think, then give us the answer. Yes, who is ready? Okay, Juma, which question are you ready to answer? Oh, question number one? Yes, come on. Excellent. A 5-sided polygon is called pentagon. It's called what? Pentagon. Who can answer question number 2 now? Yes, Zuena? Wow, bravo. The name given to the figure with the 6 sides is called hexagon. Now who can answer the last question, number 3? Yes, over there? Very good. There are 4 polygons all together. Very good job to all of you who tried also. Therefore, these are called regular polygons. Now let us have a look of the rectangular board as shown here. Use the figure to calculate the perimeter. What is perimeter? What is its perimeter? Yes, absolutely. Perimeter is equal to 6 centimeter plus 3 plus 6 plus is equal to 18 centimeter. So perimeter here is equal to 2 length plus 2 width, because rectangle has 2 length and 2 width. Then we can define perimeter as the sum of the lengths of the sides of a given polygon. What? Perimeter is the sum of the lengths of the sides of a given polygon. Polygon is inscribed in a circle. Polygon inscribed in a circle. Now let us move to polygon inscribed in a circle. Please observe the figure 2 carefully. What have you observed from the figure shown here? Oh, yes. We observed the followings. 1. Number of sides is equal to number of vertices. Number 2, there are 6 sides also and also 6 vertices. And every vertex is on the circles. Radius of the circle is equal to the radius of the polygon. And center of the circle is equal to the center of the polygon. Therefore, those observed features above are very important characteristics, for a regular polygon inscribed in a circle. Therefore, a polygon is inscribed in a circle if each of its vertices lie on the circle. A polygon is inscribed in a circle if each of its vertices lie on the circle. Now consider a regular polygon of n sides inscribed in a circle of radius r and center O, as described with the figure 3 shown here. The figure here shows a regular polygon with n sides inscribed in a circle of radius r and center O, in which there is the line AB as one side of that polygon. If the regular polygon has n sides, then angle AOB is equal to 360 degrees over n. Now angle AOM is equal to the half of angle AOB. Therefore, angle AOB is equal to the half of 360 degrees over n. And that is equal to 180 degrees over n. Now, let the length AB of the regular polygon be S. Then AM is equal to a half of S. Then from the triangle AOB, sine S is equal to 2R. And sine is equal to 2R sine 180 degree over n. Therefore, the length of one side of a regular polygon with n sides and radius r is given by S is equal to 2R sine of 180 degree over n. Remember, this is the formula for one side of a regular polygon. For only one side of a regular polygon inscribed in a circle. So, for a polygon with n sides, then its perimeter will be equal to n times s. I mean, number of sides times length of a side. This means that perimeter is equal to number of sides, which is n, times length of one side of a regular polygon. So finally, we have perimeter is equal to ns, which is equal to 2nr sine of 180 degrees over n. Sine of 180 degrees over n. Now let's see some examples. Example number 1. It says, find the length of one side of a regular 6-sided polygon inscribed in a circle of radius 10 centimeter. So here, solution. What given here is, it says, find the length of one side of a regular 6-sided polygon. So, given n number of side, n equal to 6, called 6-sided polygon. So number of sides, remember n stands for number of sides, inscribed in a circle of radius. So in the radius r is equal to 10 centimeter. Required to find the length of one side. So remember that the formula for length of one side is given by S is equal to 2r sine of 180 degrees over n. This is the formula given for the length of one side of a regular polygon as described earlier from the lesson. So then just to put the values, this is equal to 2 times r, which is 10 centimeter, then sine of 180 degrees, and n here is equal to 6. So from here, it's very simple. 2 times 10 is 20 centimeter, then it's equal to 180 over 6 is equal to sine of here 30, sine of 30 degrees, sine of 30 degrees. So here's 1 and here give you 30 degrees. So this is the same as 20 centimeter times sine 30 is equal to 0.5 or half. So finally you can simplify here 2, 1, and here is 2, 1, 0. So this is equal to 10 centimeter. So therefore the length of one side, the length of a side is 10 centimeter. Alright? Yes. Very good. So here we have just done the application of the formula. Since we know it, n number of sides are given, and the radius of the polygon, which is equal to the radius of the circle, is also given. So simply we use the formula S is equal to 2r sine of 180 degrees out of n. Example number 3 says, find the value of one interior angle of a regular polygon inscribed in a circle of radius 5 centimeter if the length of one side is 5 root of 2 centimeter. 5 times square root of 2 centimeter. Okay, let's go straight solution. Simply here, let us try to construct a circle. This is not the correct one, but let's assume it's a circle, and the circle has the center O. And let's say we have a triangle like this one. Yes. So this is the radius of the circle, which is equal to 5 centimeter. And if we draw a perpendicular line, we have a right angle triangle there. The whole line here, it says inscribed in a circle of radius 5 if the length of one side, and this is the length of one side. Let's say here is A. So let's say here is A and here is B. So the length AB is 5 centimeter. So what we need, if you consider only this if you consider only this here, let's say here is x, only xb, it will be a half of that. So if AB is equal to 5 root of 2 centimeter, then XB going to be a half of that, is 5 over 2 root of 2 centimeter. Now, the question says, find the value of one interior angle. This one interior angle, this, of a regular polygon. Let's call it theta. So you want to find out the value of this interior angle of that regular polygon inscribed in a circle. We never know, we don't know how many sides are there because it's not mentioned. Okay, good. So from that, we can see that if you take cos of angle theta, if you take cos of that angle theta, this is equal to adjacent over hypotenuse. I hope you remember that. And adjacent here is the line XB, which is 5 over 2 root of 2 centimeter, divided by the hypotenuse now here. This one is the R, which is equal to 5 centimeter. Hypotenuse here is equal to 5 centimeter. And centimeter, 5 and 5 there. So I'm going to have cos of angle theta is equal to root of 2 out of 2. If we need theta is equal to cos inverse of root 2 out of 2. And what is the cos inverse of root 2 over 2? You have theta is equal to 45 degrees. So therefore, the question says the radius, the question says we were supposed to find out the value of one interior angle. Find the value of one interior angle. So therefore, the value of one interior angle. Therefore, the value of one interior angle is 45 degrees. Are we together? Yes. So these are some of the examples concerning perimeter of the regular polygon inscribed in a circle. I hope you followed well the examples. Then they can help you to attempt the following exercise.
Dear viewers, let us remind ourselves now from the lesson. Let us remind ourselves before we close our session today. First thing, perimeter is the sum of the length of a polygon. Sum of the length of a polygon. We call it perimeter. A polygon is inscribed in a circle if each of its vertices lie on the circle.
Another thing is what? A polygon is regular if the length of its sides are equal. But also, another thing is what? The length of one side of a regular polygon with n sides and the radius r is given by S is equal to 2r sine of 180 degrees over n. S is equal to 2r sine of 180 degrees of n. And perimeter is equal to ns, which is equal to 2nr sine of 180 degrees over n. This is your exercise now. Find the length of one side of a regular 9-sided polygon inscribed in a circle of radius 10 centimeter. That is number 1. Question number 2, find the radius of a circle which inscribes an equilateral triangle with perimeter 24 centimeter. That question number 2. Number 3, find the area of a 9-sided polygon inscribed in a circle with a radius 5 centimeter. Dear viewers, here is the end of the lesson today. Here is the end of the lesson today. I hope you enjoyed lots. Until next time, bye-bye.